Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS 3551 Distributed Computing. The unit is Distributed Mutex and Deadlock. In this video, we are going to discuss about deadlock detection in distributed systems, introduction, system model, preliminaries and models of deadlock. Introduction. Deadlock is a fundamental problem in distributed system. A process may request resources in any order which may not be known a priori, and a process can request a resource while holding others. If the sequence of the allocations of resources to the process is not controlled, deadlock can occur. A deadlock is a state where a set of process request resources that are held by other process in the set. System model. A distributed program is a composed of a set of n asynchronous processes P1, P2 to Pa to Pn that communicate by message passing over the communication network. Without loss of generality, we assume that each process is running on a different processes. A processor do not share a common global memory and communicate solely by using the message passing messages to over the communication network. A process can be in the two states. One is running state or otherwise in blocked. Running means that is also called active state. A process has all the needed resources and either executing or ready for execution. Blocked state means a process is waiting to occur some resources. Wait for graph. The state of the system can be modeled by using the directed graph called wait for a graph. The WFG nodes are process if there is a directed edge from node P1 to node P2. Then if the P1 is blocked and it is waiting for P2 to release some resources. A system is deadlocked if and only if there exists a directed cycle or not in the particular wait for graph. Preliminaries for handling the deadlock. There are three strategies for handling deadlock. First one is deadlock prevention, then second one is deadlock avoidance, then third one is a deadlock detection. Handling of deadlock becomes highly complicated in distributed system because no side has accurate knowledge of the current state of the system, because every interstate communication involves a finite and unpredictable delay. Deadlock prevention is commonly achieved either by having a process occurring all the needed resources simultaneously before it begins executing or preempting a particular process which holds the needed resources. In the deadlock avoidance approach to distributed system, a resource is granted to a process if the resulting global system is safe. However, due to several problems, deadlock avoidance is impractical in distributed systems. Issues in deadlock detection. Deadlock handling using the approach of deadlock detection entails addressing two basic issues. First one is detecting existing deadlock, and second one is a resolution of detected deadlocks. Detection of deadlock involves addressing two issues: maintenance of WFG and searching for WFG for a presence of cycles. The correctness criteria. The deadlock detection algorithm must satisfy the following two conditions. First one is progress, then second one is a safety. Progress means no undetected deadlock, then safety means no false deadlocks. Models of deadlock. Distributed systems allow several kinds of resource requests. First one is a single resource model. In the single resource model, a process can have at most one outstanding request for only one unit of a resource. Since maximum out degree of a particular node in a wait for graph for a single resource model can be 1, the presence of the cycle in the WFG shall indicates there is a deadlock. Then second model is the AND model. In the AND model, a process can request for more than one resource simultaneously, and the request is satisfied only after all the request resources are granted to the process. Then next one is the R model. In the R model, a process can make a request for numerous resources simultaneously, and the request is satisfied if any one of the requested resources is granted. Then next model is the AND OR model, a generalization of the previous two models. OR model and OR model is the AND OR model. In the AND OR model, a request may specify any combination of AND or OR model in the resource request. Then next one is a P out of Q model. This is a variation of AND OR model. It allows a request to obtain any k available resources from a pool of n resources. It has the same in expressive power as the AND OR model. Next one is the unrestricted model. In the unrestricted model, no assumptions are made regarding the underlying structure of the particular resource request. Only one assumption, that the deadlock is stable, is made, and hence it is most general model.